and welcome to another session of writing a Firebolt data app using Java. So today we will dig a little bit through Java code. We will take a look at the GitHub archive data again and see how we can write a small application where every user can look up their own statistics across GitHub. Let's get started. So this will be the starting page of our app. As you can see, nothing big. The only number exposed is the total number of events that we are about to search through. And the interesting part here is the login button at the top. So once we log in, we will be able to see our own statistics. Before we go further, just a quick refresher about the GitHub archive data. You can find it on gharchive.org. And this is basically a dataset that contains every public event happening on GitHub on an hourly basis. So it consists of gzip JSON files. You can download them and index them into any data store. And I just used Firebolt for this. So going back to our web page here, the thing that you can do is do a login. So in order to log in, we will utilize GitHub. So we do not have to store our own username and passwords, which means that as a user, I have to allow this application to access my profile information as a read-only pattern. So once this is done, we basically get redirected back to our web page. And we already see the results over here. So we do see the profile page of my user, the profile picture of my user. We do see the number of events grouped by the event type. And we also see the number of events grouped by the year. So let's step through this one by one. First, we have searched across 5 billion events. And then my most active year was 2018. The data collection starts at the 1st of January 2015. So there's no surprise that this is the start of the data collection. In total, there have been over 6,400 events that I triggered on GitHub that have been logged. And most of them have been code pushes. This is not surprising as well. And also that I interacted across 195 repositories. Keep in mind that this includes forks. So if I commented on another fork of another user, this also will count as separate repository. Also that I worked on the Elasticsearch codebase demos is not surprising, as I did this for a couple of years. And interesting enough, I have never triggered a public wiki event. So adding a wiki, changing data in a wiki is something I've apparently never done. So on the right side, we see the grouping by event type. We see the grouping by year, and also there's a small graphic showing the activity by year with a small dip over here in 2020 or since 2020. This is the lower line, and a high at 2015, which then got a little bit lower. So those are the stats. Let's take a look how this is actually implemented. So this is my Java project. It's a Gradle-based project. And as you can already see here on the left, we basically only have 6 classes in here. One of them an interface, one an enum, one an annotation. So the core logic of all of this is in the app class. On top of the Java classes, we also have a couple of templates. We're using JTE, a templating language for this project. So let's take a look at the app class. The app class is the core, which starts up the web server. So this is using Javalin, lightweight Java web framework. And you can see here, we start running the web framework. The most important part from a Firebolt perspective is setting up the database. And this happens with setting up JDBI. So in order to be able to use JDBI, we basically have to do a JDBC setup. And Firebolt has a JDBC driver. So all we have to do is instantiating this driver with the proper credentials, then hooking up this driver to JDBI, and then we can make use of JDBI, and I will show this in a second. The core to this is basically getting the JDBC URL right, and in the background, once you've included the dependency of JDBC, everything else is sort of happening automatically. We just have to make sure that the endpoint, the engine, and the database and the password is set. Once this is done, we basically get back a JDBC connection that we then can use to instantiate JDBI. So the core question here is now, what do we gain from JDBI? And this is something that can be shown in the interface class, the GitHub DAO. And if we take a closer look at this one, it basically is just an interface that contains a couple of methods which are annotated with a SQL query annotation. And what is basically happening internally is that this SQL query is executed whenever this method is called, but I, as a developer, do not have to implement any implementation of this interface. It's basically handled by JDBI in the background. So whenever I call GitHub profile DAO fetch all event types, we will just get the number of different event types within our dataset. We have a couple of those methods, so we also count the number of repositories I've interacted with. This is something you saw earlier. We also just have a total count that we are interested in. And thanks to Java's multi-line formatting, it's also somewhat easier to write a little bit more readable queries. So if you have a longer query like this one, where we basically filter on the user account again and then just count for each of the event types that have been found, so this is on the left navigation bar, we can write it like this. The same also applies to the activity on a yearly base. Again, we can just use the year, count the number of events, filter by login, and the login is always the method parameter that I can hand over. So the idea here is the same. You can see here, I still have a slow query that needs to be fixed on the Firebolt side of things, like using an aggregated index. So this is marked as such. But the basic idea here is you write your queries, you write your SQL. You probably have some more annotations if you want to specify to store this in a hash map, for example, optionally, or you just return a single long. All of this is handled automatically by JDBI. And the only thing that I basically put on top is this cached annotation. So if we take a look, this is a pretty standard definition of an annotation. The other interesting part here is the SQL method decorating annotation. So what I've basically done here is setting the caching handler decorator. I added the functionality to cache the response of the queries based on the name of the method in the DAO, and of course based on the parameters that have been supplied, so that cache entries with different users don't overwrite each other. And the idea of this is, while I'm super sure that a database is really fast, this is data that doesn't change a lot. So whenever a user opens up their page, you can be kind of sure that he's probably opening it up soon again. So caching this just saves a complete database query, which, while it would be fast, is probably still not needed if you can cache things locally and just have them expire over time. And this is exactly what I did here. And that's also the reason why the page renders super quick after it has been loaded for the first time. So if we go back here and I hit reload, you can see in the top that while we're hitting reload, the rendering of the page is really, really quick because all the data is basically just looked up in a hash map or in a cache. I'm using caffeine as a cache builder here. So that is the basic logic of this application. You may want to go back and look a little further. So when we start up the app, we set up our GitHub profile DAO, which is then used. We have to check if we are in production or not, because when we are in production, we can pre-compile our templates, so we don't need to do this on startup. There's some setup for the Javalin app. There's the setup for the GitHub configuration, so that we can log in via OAuth and retrieve back the data from GitHub, which is really, really useful because, again, we do not want to store any usernames or passwords within this application. This also means we really don't write any data. All we need to do is querying the database as a read-only user, and that's about it. And then we have our main page here that gets called, and depending if you're logged in or not, you're either redirected to your GitHub statistics or you're redirected to the login. So I'm logged in right now and I get redirected to my GitHub statistics. Also, we want to make sure that we are basically logged in if we are taking a look at these stats. So I can only take a look at my own statistics once I'm logged in. And right now, how this little tool is implemented, I would also not be able to take a look at statistics of others. But that's something that, of course, would be easy to change. And this is basically where all the logic happens, or the main logic happens for the stats. So the stats GitHub login, like stats spin scale in my case. We do run a couple of lookups for the GitHub profile data DAO. We do run and then we store all of those in a map, and this map is basically used for rendering. And then we just access all of these variables which have been defined over here within our template and display all the values that need to be displayed. And that is already it. So as I said, this is just a small app to show you how to get up and running. If you know how to set up JDBC in a Java application, then setting up Firebolt is really quick. All you need to do is basically including the dependency, the Firebolt JDBC driver, and that's about it. You can take a last look if you want to know more on the Firebolt JDBC driver. It's just over here in GitHub. You can file issues, test it out, see if it works for you, and then go from there. That's it for today. Thank you for listening, and see you next time.